Yes, so Srikal students, well, let's start the chapter friction, the sub chapter friction in laws of motion, class 11. So what is friction? We know that it's a opposing force. What are the types of friction? We have external friction and we have internal friction. Well, what is all this? Well, normally, let's say there's a surface. On this surface, if this is a some body is placed on the surface, if we apply the force, some effort P, on the opposite side, there is a force of friction between the surfaces, right? This is known as external friction. This is force of friction. Internal friction, like if you talk about liquids, flowing liquids. So the liquids are flowing. There are so many layers inside the liquid. Liquid flow of liquid can be imagined as flow of infinite laminas. Laminas, layers. In between the layers, there is friction because all the layers of the fluid, like for example, if you talk about a fluid flow in a circular pipe, interestingly, the velocity of the layer which is in the center of the pipe is having maximum velocity. The layer which is in touch with the both the surfaces, surfaces, these surfaces, not both the surfaces, internal surface, they have zero velocity, no slip condition. And as we move towards this surface, towards the center, the velocity increases. That means every lamina of the fluid has different velocity. And whenever there is a relative motion, remember students, if there are two surfaces, both the surfaces are moving with the same velocity, there is no friction between them. Friction occurs only when there is a relative motion, means when one object starts sliding or rolling over the other surfaces. In the sense, we can say there is a relative motion between two objects, then the force of friction comes into play. Okay, force of friction as such does not exist. It exists only when there is an effort applied on the body. So this force is known as internal friction. The force of friction between different layers of liquid. We can say fluid also. Any liquid or gases, even gases are supposed to, you know, you know, uh, flow in, layers. So these are this is external and internal friction. This internal friction is also known as students viscosity, which we will be studying in detail in the chapter mechanical properties of fluids. Viscosity, right? Well, this is done. Now we have what are different types of frictions. We have done external and internal friction. Okay, so now external friction is again of three types. What is that? One, two, three. One is static friction. Static. I'm assuming that all the girls are writing down whatever I'm discussing. And anytime you have any doubt, stop me, ask me. Then limiting friction. Limiting friction. And then we have kinetic friction. Or we can also call it dynamic friction when the body is in motion. Dynamic friction. Let's discuss one by one. What is static friction? The static relates to stationary. So see students, very simple. I've explained you yesterday also. This is a body. Okay. Now, very important thing I'm going to introduce. The weight of the body always acts downwards. Everyone knows. Mass is m is the mass of body multiplied by acceleration on the earth. We're talking about earth. Then weight, that is the weight of the body on earth. Maybe different at different planetary objects or different cosmic objects. So now students, if this is the mg, This surface is giving a reaction to the body up in the upward direction. This reaction R is known as normal reaction. R is normal reaction. Always normal reaction is perpendicular to the surface. If the body is on an inclined plane, again the weight of the body will occur downwards and the normal reaction again be given by the surface on the body. It will always be perpendicular to the surface. This is your surface. Which surface? On which the body is stationary or body is rolling or body is sliding. Okay, this is normal reaction. Okay, students. So in this case, when the body is at rest, I can say R is equal to mg. That is normal reaction is equal to weight of the body. Okay, now let's see. I apply this force on the body P. Okay, let's say I apply P force on the body. Okay, now I'm applying P force on the body, and as I'm applying P force on the body, in between these surfaces here, entirely on the surface in contact, there is a force of friction which acts in the opposite direction. This is force of friction. Now if I apply a little bit more force, but make sure the object is not moving. Apply very little force, there will be force of friction. Apply more force, there will be force of friction will increase. Then apply more force, make sure it's not increasing. Just increase the force, step by step. It's not moving. Force of friction is again increasing, right? So don't move the object. See the maximum force you can apply where the object is not moving. So from this small experiment we understand that static force is self-adjusting in nature. Self-adjusting. What is the meaning of self-adjusting? That it adjusts according to the force applied, right? So I can say P force applied is equal to F. F is a friction, P is the force applied, and that is self-adjusting. When effort is very less, force of friction also very less. As it increases, this also increasing. Then does it really keep it increasing? No, 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 not exactly. Then what happens? Okay, how can we define static force? It is the opposing force, static friction, not static force. We can say static force of friction. We can define it as opposing force that comes into play when the body tends to move over the surface of another, but actual motion has not started, is known as static friction. Remember, students, till the actual motion has not started, the force of friction, which is acting in the opposite direction of effort, or you can say force applied, is known as static friction. Static for stationary, the body is not moving. Okay, fine. If the body is not moving, simply the body is on a surface and I'm not applying any force, there is no force of friction. Remember, no force of friction. When small force is there, but the body is not moving, force of friction comes into play. Okay, now what happens? Slowly I increase the P, and then comes a situation. Students, when the body just starts to move. Just starts to move, or you can say slide, or you can say roll. Okay, so here now I'm applying P, and at that point the P is maximum, the maximum force I have applied, to convert the state of rest of the body into, yes Ishma, state of motion. Okay, So that maximum value of effort where the body just starts to move, then the force of friction, which is self-adjusting in nature, the static force of friction, that has also reached its maximum value. This maximum value of force of friction when the body just starts to move is known as limiting value of force of friction, or in short we can say limiting friction. Limiting friction is the maximum opposing force that comes into play when the body is just at the verge. Verge means just about to, just at the verge of moving over the surface of other body. All right, students, this is our limiting friction. Yet another type of friction we have, that is, what is that? Kinetic friction. This is kinetic friction, or it is also known as dynamic friction. What is this kinetic and dynamic friction? Now, students, you know, now here I want to plot a graph. This is force of friction, and on this is applied force. Applied force, that is P, and this is force of friction. So initially the body was at rest. Okay, then when I increased the applied force, force of friction also increased. There was a linear relation between applied force and force of friction. Then I observed at this point was the maximum value of the force of friction. What is this value known as? Any student, just now I told you. See, I applied force more. The body was at rest. Then the body just starts to move. At that point, the force of friction was at maximum peak, and that maximum value is known as, yes, Jasmine, that Ishma, Jasmine, anyone, that maximum value of force of friction is known as, come on, this value is limiting friction. Okay, from here to here, this is static friction. Static friction, which is changing, and maximum value is limiting friction. Then, students, kinetic friction. Okay, we'll draw the graph later. Just now we'll first discuss kinetic friction. Okay, now when we increase the applied force slightly beyond limiting friction, actual motion starts. That doesn't mean the friction has disappeared. Motion has started. It doesn't mean there is no friction now. No, friction is there, you know. But only thing we want to say that now it's little bit easier to move the object. This was my object. First I started this much force. It didn't move. I increased the force. It didn't move. I increased the force. This was P. That was the same, was the limiting value of friction. Limiting value of force of friction. Then here limiting value of force of friction, body just started to move, and then again I increased the force. You know what, body started moving. When body started moving, the force of friction has already reached its maximum value. It will not go beyond it. In fact, students, now I feel that the maximum effort which I have applied, now I have to apply less effort to make the body moving. That's really strange. You know, you could also relate it to a lot of things. The way interlockings are done. Now, when the body is in motion, there are interlockings. These are like interlocking. Like the surfaces are there, na? The surfaces of the upper body and lower body. These are interlockings. So their reaction is there. So there is no sufficient time. Time is very less when the body is moving. So interlocks get very easily destroyed and the body keeps moving. The force applied is less, and then that when force applied is less and when the body has started moving, the friction which is now acting in the opposite direction is kinetic friction or dynamic friction. In simple words, we can say when a body is moving over the surface of other body, between the surface contact, the force of friction is known as kinetic friction or dynamic friction. Okay, students. Now my effort is already reached maximum value. It decreases and then my effort remains constant to make the body in motion, right? So this is A to B curve. A to B is little down in the effort, and then C, and then you can say this is O to A. I keep increasing force, friction is also increasing. Okay, so we can say the as the P is decreasing, effort is decreasing after the body has started moving. Body is now having inertia of motion. That inertia of motion is also helping the body to move. So the force of friction also decreases little bit from the maximum value. Maximum value was limiting friction. So now the force of friction is known as kinetic friction. I can say the kinetic friction is always less than the limiting value of friction. Okay, so I've done this. Okay, now students, the kinetic friction is also divided into two categories. Kinetic friction, because the body may be sliding, the motion may be sliding, or the motion may be rolling. So there is a rolling friction and sliding friction. Okay, fine. Now comes laws of kinetic friction. We are going to study the laws of kinetic friction. Well, what is kinetic friction? Value of kinetic friction is little less than the limiting value of friction, and kinetic friction comes into play when two bodies are in relative motion between each other. Now the first law. Alright guys, let's go for the first law. Okay. The force of kinetic friction, Fk. Force of kinetic friction is directly proportional to the normal reaction. Very, very important law. See, the body is in motion. This body is in motion. Force applied is P. This is now body is in motion. So I don't talk about static friction. I don't talk about limiting friction. Rather, I talk about, yes, Ishma, kinetic friction or dynamic friction. Okay. So this is the weight of the body always acting downwards, even when the body is moving. And reaction, normal reaction is R. Now students, very important law. What? The force of friction, and this is particularly force of kinetic friction, is directly proportional to normal reaction. That means more is the mass of the body, more will be R, more will be friction. Remember, the force of friction is not directly proportional to mg. This is very important. It's not directly proportional to weight of the body. It is directly proportional to the normal reaction. Why I said that? See here. Suppose the same body is on inclined plane. Okay. Let's say its inclination is theta or alpha. The weight again will be acting downwards mg, but now the normal reaction is less than mg. It is R. So force of friction has decreased. It's not directly proportional to mg. Force of friction is directly proportional to normal reaction. As the theta increases, R decreases. And students, when theta is 90 degree, anybody can tell me what is the value of R? There is no normal reaction. Now, when the body starts falling down from here, there is no normal reaction. This R becomes equal to 0. So normal reaction is changing. Normal reaction is maximum when the body is at rest on a horizontal plane. Then in this case mg is equal to normal reaction r. Remember that as it is increasing, as the inclination is increasing, r will be decreasing, and at 90-degree r becomes 0. Okay, so this is interesting. All right, so remember, force of friction is not proportional to weight of body. It is proportional to what is R? R is, come on students, I would be happy if somebody speaks. What is R? Ishma? R is normal reaction. Very important. Okay, so when say F, force of kinetic friction is proportional to normal reaction, obviously when we remove the constant of proportionality, we will get a constant, that is coefficient of kinetic friction. We have coefficient of static friction also, and coefficient of kinetic friction would be slightly less than coefficient of static friction. When the coefficient of static friction comes into play, when the body is at rest. Now the body is in motion, this body is moving, it's in motion, it's in motion. When the body is at rest, again the force of friction. At rest, at rest, this is the body is at rest, this is the weight of the body, mg. This is the normal reaction, which is equal to mg. I am applying a force p. I'm applying a force p, but the body is not moving. Okay, and in this is force of friction. Now this F, I can write Fs is proportional to again R, and Fs would be equal to mu sr. What is mu s? Coefficient of static friction into r, and in this case coefficient of kinetic friction into r. So I can say mu k, that is coefficient of kinetic friction. Kinetic friction is equal to force of kinetic friction, or kinetic friction divided by R. Force of kinetic friction divided by R. This is first law. The second law is, students, you may be thinking that if there is a tire, tire is moving on a, road, you may be thinking, the wider is the tire, more will be friction. Not exactly. This was an older view. The for kinetic friction does not depend upon area of contact. Area of contact. It doesn't depend upon area of contact. Remember that. Okay. Number three, we'll prove it also. We can prove it also. Number three, force of kinetic friction is also independent of speed of sliding. At what speed the body is sliding over the surface of other body, or the body is rolling. That means once the body starts, body has overcome the limiting value of friction, then the force of kinetic friction is constant, which I mentioned yesterday also. Number one, force of friction, kinetic friction is directly proportional to normal reaction, not proportional to weight. Number two, force of kinetic friction doesn't depend upon area of contact. Number three, doesn't depend upon speed. At what speed, whether you are at greater speed, lower speed, you know, after limiting value of friction, after limiting value of friction. This is the force of kinetic friction. This is constant. This is force of limiting friction. And all these are different force of static friction. Force of static friction does not have fixed value, but limiting force of friction and kinetic force of friction both are constants. Both are constant. Their value does not change. Sometimes we really feel, when a body is very, very fast, more inertia of motion is developed. Maybe the friction force will further decrease, but till now, till late, we are assuming that it's constant. Okay, we think it's constant. Okay, okay, guys, let's go further. Okay, now comes what are the causes of friction? Well, please study yourself. It's about interlockings and it's about force of cohesion. Force of cohesion is between same particles. Same particles means, let's say iron is sliding over iron surface, then a wood is sliding over iron surface. Now there is a force of adhesion, force of adhesion, force of cohesion. So these also, these atoms of wood and iron, they also have forces of attraction. That also gives rise to force of friction. And the irregularities, I'm going to say that the interlockings, okay, fine. So that depression and the mount or bump, like when a wheel is moving, when the wheel is moving like this, so this surface becomes like this. So this we have wheel has to put some extra force to overcome this, or you say this is the reaction, on the opposite side, that accounts for force of friction. Okay, when it's moving in this direction. Okay, fine. So we have also discussed self friction. Static friction is self-adjusting in nature. Now comes laws of limiting friction. Okay, so we've already discussed, and students, you can study yourself the experiments to prove those laws. For example, one law, I said force of friction doesn't depend upon area of contact. You see that you can prove this law like there's a pulley, there's a weight attached. Okay, now there's a hook, and you can have two blocks. Okay, now two blocks are there. Now they may have different weight or same weight, no problem. Now this is the R1 of first block, this is R1 of second block. And what you can do the experiment like this, and then you can put this block over this, and then you will find that the same weight is required to move them. You see, the normal reaction is same in both the cases. R1 and R2, R1 and R2 is same, but the area of contact has changed. So, but the same weight is required to pull both. That means force of kinetic friction does not depend upon area of contact. Similarly, give yourself some good reading about the proof of other laws. And now we can go for coefficient of friction. Okay, coefficient of friction. Coefficient of friction. All right. So see students, force is frictional force is directly proportional to normal reaction. F is equal to mu into R. Mu is equal to F by R. All right. So coefficient of limiting friction. Okay, now this is coefficient of limiting friction. Then this will be limiting force, and this will be coefficient of limiting friction is limiting force by R. Similarly, you can find coefficient of kinetic friction is equal to what? Kinetic force of friction divided by R. Okay, not much. And this coefficient of friction depends upon what? This depends upon material of the surfaces, and then temperature of surfaces, and then it also depends upon nature of surfaces. Nature of surfaces. They are dry or they are wet, they are rough or they are smooth, they are polished or they are non-polished. Okay, and then we've also seen force of kinetic friction is little less than the force of limiting friction. Simply F means force of friction, force of limiting friction. All right. And then there are different materials, like if you have wood on wood, so the force of limiting friction is 0. Sorry, the coefficient of limiting friction is 0.7, and coefficient of kinetic friction means when the wood starts moving over wood, that is 0.4. All right. Then you can write steel on steel. So you have some steel, you try to move steel over some steel platform. The coefficient of limiting friction is 0.78, whereas the coefficient of static friction, the coefficient of static friction for steel on steel is something like 0.0.57.
Yes, sir.
You're in the meeting. Okay, that's good. Now, students, we have, then we have angle of friction. Angle of friction. What is this angle of friction, guys? See that this is a block. Let me define it. Angle of friction between any two surfaces in contact is defined as angle which is the resultant of force of limiting friction. Resultant of force of limiting friction. I'll simply write F and normal reaction. Resultant of these two. Resultant of force of limiting friction and the normal reaction makes with the direction of normal reaction. Makes with the direction of normal reaction. Let me just tell you. See, whenever there's a case of limiting friction, that means there is no motion. Whenever there is a motion, then we will always talk about kinetic friction, right? And when we are talking about force less than limiting value of force of friction, then it is static friction. Static friction, limiting friction, kinetic friction. ठीक है, बहुत कम फोर्स लगा रहे हैं, बॉडी मूव नहीं कर रही है, बॉडी जस्ट मूव करना स्टार्ट हो गई है, बॉडी ने मूव करना स्टार्ट कर दिया. Static friction, limiting friction, and kinetic friction. All right, guys. So we have done this, and now let's say this is P. Okay, this is my resultant R. My mg is here, and this is my force of friction. Now you see force of friction F and R have this as resultant, and this angle theta means this resultant of F and R which makes with R is known as angle of friction. And you see, students, mu is equal to tan of theta. We'll take this up in detail in the next lecture. Wish you all the best, students. Yes, do write any doubt if you have in the comment section. All the best, and don't forget to, if you like the video, subscribe our channel, Learn CBSE.